In question 47, it says a small mailbag is released from a helicopter that is descending steadily at 1.5 meters per second. After 2 seconds, we want to know A, what is the speed of the mailbag, and B, how far has it fallen below the helicopter? Now, part C, we're going to repeat part A and B calculations for a helicopter that is steadily rising at 1.5 meters per second. Okay, first things first, let's go ahead and draw a small sketch of what's happening here. Okay, now it's telling you that a small mailbag is released from a helicopter that is steadily descending. So steadily, constant velocity. Descending, going downward. So in other words, we know the downward velocity is 1.5 meters per second. Now, that's not only the downward velocity of the helicopter, that's the downward velocity of the mailbag as well. Now, after 2 seconds, we want to know how fast the mailbag is going, because basically, here's what's going to end up happening. The helicopter is descending steadily, and at a certain point, the mailbag is going to be released, and the mailbag is just going to fall, and it's going to accelerate due to gravity while the helicopter keeps slowly descending. This is an example of a constant acceleration problem, or due to gravity, or a free fall acceleration problem. When we list our concepts, okay, we want to try to identify them as thoroughly as possible. We know it's a free fall acceleration problem because once that mailbag is released, it's going to pick up speed. It's going to pick up velocity due to Earth's gravity pulling on it. Now, we want to know what is the speed of the mailbag, okay, when it's far below the helicopter. So, if I want to know, let's list our variables before we start trying to identify an equation. Y, y naught, v, v naught, a, which is equal to negative g, or 10 meters per second squared, and t for time. Okay, now the only thing we know to start off this problem is that it's going downward, and we know that it's going downward at 1.5 meters per second. So the initial speed when the mailbag is released is also that same descending speed, 1.5 meters per second. Since the mailbag is going down along with a helicopter going down, it should be a negative 1.5 meters per second. We want to know the velocity 2 seconds later. Using that list right there, we can see the first equation is going to be the most helpful. So for part A, V equals V naught minus GT. Plug in. V equals negative 1.5 minus 10 times 2. And 10 times 2 is, of course, 20. Negative 1.5 minus that is negative 21.5 meters per second. What does this velocity mean? It means after 2 seconds, the mailbag has a speed of 21.5 meters per second going downward. Part B, we want to know how far below it is below the helicopter. Now, to tackle part B, what we want to be able to do is we want to be able to find the position of the mailbag and the position of the helicopter after this time, after 2 seconds, and then compare the two, subtract the two positions. So we have two objects that are essentially moving in the same reference frame in part B. We have the helicopter, moving with constant velocity downward, and we have the mailbag, which is moving with constant acceleration due to gravity, right? Or free fall acceleration. Well, let's go ahead and make simultaneous lists here for these two concepts. In the case of the helicopter, it's going to be y, v, and t instead of x, v, and t. And for the mailbag, it's going to be y, y naught, v, v naught. A is equal to a negative g, or 10 meters per second squared, and t. So I'm going to call this YH, Y of the helicopter. I'm going to call this YM, Y of the mailbag. Well, velocity of the helicopter remains the same. After the mailbag is released, the velocity of the helicopter is still negative 1.5 meters per second, and we were told that after 2 seconds we want to find this information. Y is equal to V times T, or negative 1.5 meters per second squared times 2 seconds. The helicopter is at a position of negative 3 meters. What does this basically mean? Helicopter has lowered itself by 3 meters. Lowered the negative. Now we can look at the position of the mailbag. If the helicopter only reduced its position by 3 meters, how far did the mailbag go down? Once we know how far that went down, we can subtract the two positions and we can get how far below the helicopter the mailbag will be after 2 seconds. So I want to know this value right here. Now, the mailbag itself, we're going to essentially call this 0. We're going to call the initial position of the mailbag at 0 when it's released, because we can assume that the mailbag is in the helicopter. I mean, it doesn't tell us any different. It doesn't tell us it's hanging 3 feet below the helicopter. It just says it's released from a helicopter. So we're going to assume that it has the same position as the helicopter at the moment it's released. So we're going to talk about a position of 0 there. The final velocity after the bag is released, we found that to be negative 21.5 meters per second. That was this information here. And the initial velocity of the mailbag is the same as the helicopter's descending rate of negative 1.5 meters per second. And then time is again 2 seconds. So, based on this, the best equation we can use for this part would be, I'm going to call this Ym, is equal to Y naught plus V naught T plus 1/2, minus 1/2 GT squared. Cancel anything that goes away. That was equal to 0. And now we can plug in. The position of the mailbag, we have negative 1.5 times 2 minus 1/2 times 10 times 2 squared. Well, 2 squared is 4 times 10 is 40, take half of which is, of course, 20. And what this answer means is the mailbag is 23 meters lower after 2 seconds. So finally, to figure out how far this is going to be below the helicopter, we just simply need to subtract the positions. If we take the position of the 3 meters below and the 23 meters below, that means the mailbag is 20 meters below the helicopter. In other words, we're subtracting the absolute value of these positions, 3 and 23. Okay, lastly, for part C, we're going to repeat part A and B, but since we know what to do for part A and B, we know what equations to use, we're simply going to substitute one value, and that's this. For part C, the initial velocity is positive 1.5 instead of negative 1.5. In other words, instead of the helicopter lowering itself and releasing the mailbag, it's going to be rising and releasing the mailbag. Well, if we take a look at the velocity calculation, let's start there. V equals V naught minus GT. That would be 1.5 minus 10 times 2, or 1.5 minus 20, which is negative 18.5 meters per second. So if it's going up, it's going after 2 seconds, it's going to have a slightly slower speed because it's got to slow down as it's going up and then come back down. Whereas if it's already going down, it has a downward velocity, and then we add to that the velocity that it picks up as it accelerates. Now, to get the position below the helicopter, how far is it below the helicopter? We need to redo these calculations. So y of the helicopter is equal to v times t, or 1.5 times 2, or 3 meters. The helicopter has gone up 3 meters. The mailbag, on the other hand, it's going to go up and then down. So let's fill it out. 1.5 times 2 minus a half of 10 times 2 squared. 2 squared is 4, times 10 is 40, take half, that is 20. And instead of going negative 3 minus 20 to get 23, we're going 3 minus 20 to get negative 17. What this means is the mailbag is still $20 meters below the helicopter. Let's see how this works visually. Okay, I'm going to compare the two. Here's the helicopter, and it went down and lowered itself by 3 meters. Now this is part B, mind you. Whereas the mailbag, which I'll do simultaneously over to the side here, starts at the same level of the helicopter, but then has fallen and is now 23 meters lower. Well, if we compare, the difference in those positions, of course, is 20 meters. Now, if we do this side by side, with a helicopter that now went up. Okay, and the helicopter is now 3 meters higher. Okay, and the mailbag would go up and then down again. And it's going to end 17 meters lower. Well, if I take these 17 meters and those 3 meters, it of course adds up to 20 meters between the helicopter and the bag.